guys, welcome back to Striking Studies. So today we're going to be doing Force and Laws of Motion Part 2. So basically in this part we're going to first know what is Newton's first law of motion, because this chapter is about laws of motion. So yeah. So every object continues in its state of rest or uniform motion in a straight line unless it is compelled to change that by forces impressed upon it. So this was built on Newton built this law on top of Galileo's observations on inertia. So what's inertia? Inertia is the natural tendency of an object to remain at rest or in motion at constant speed along a straight line. Inertia of an object can be of three types: inertia of rest, inertia of motion, inertia of direction. So, inertia of rest is basically the tendency of an object to remain at rest. This means that an object at rest remains at rest until a sufficiently large external force is applied on it. Examples of inertia of rest are, first one, when you're sitting in a stationary car and the car suddenly starts, then the car accelerates forward, so you would be pushed back against the seat. This is because the lower part of your body comes into motion as it is in direct contact with the car floor, while the upper portion still remains at rest due to inertia of rest. And if the speed of the car increases slowly, you will not feel a push or jerk because the inertia of motion will get transferred to the whole body. The second instance is when you move a hammer with a loose hammerhead in downward motion and suddenly stop it on a floor or wooden base, the hammerhead gets tightened. This is because the handle of the hammer comes in motion while the hammerhead remains at rest due to inertia of rest. And the third one is that when a blanket is given a sudden jerk, the dust particles fall off. This is because the blanket suddenly comes into motion, but the dust particles remain at rest. As a result, dust particles get separated from the blanket. Now we're going on to inertia of motion. So inertia of motion is the tendency of an object to remain in the state of uniform motion. This means an object in uniform motion continues to move uniformly until an external force is applied onto it. So some of the examples of inertia of motion are when you are driving a car and you apply brakes to stop the car suddenly, you feel as if your body is being pushed forward because your body resists the decrease in speed. The lower part of the body comes to rest as it is in direct contact with the car floor, while the upper portion is still in motion. And if you stop the car by decreasing its speed slowly, you will not feel a push or a jerk because inertia of rest will be transferred to the whole body. The second example is that when a person jumping out of a moving train has the tendency to fall forward. So this is because on jumping, his feet come to rest as they touch the ground, but his upper body continues to move forward due to the inertia of motion. Now, the third inertia is inertia of direction, and this is basically the tendency of an object to maintain its direction. So the first example for this will be when your car takes a sharp turn at a high speed, you tend to get thrown to one side. This is because of inertia of direction. So if your car takes a left turn, you will be thrown to the right side. And the second example is when a wheel rotates at high speed, sand particles fly off the wheel tangential along a straight line due to inertia of direction. And now we're going to learn about linear momentum or just momentum. So linear momentum of a particle that has mass m moving with velocity v is defined to be the product of mass and velocity. Basically, linear momentum which is known by the symbol p, is equal to mv. So p equals mv, and that's very important. And the SI unit of this is kg meter per second or kg meter per sec kg meter second to the power of -1, which is basically the same thing. And the linear momentum of a particle is directly proportional to its mass and velocity. So the fact of this video was Galileo discovered inertia and Newton built law based on it, like I said in the beginning. So that's all, the end of part 2, guys. Meet you next week. Bye, guys. If you like this video, don't forget to like, share, and subscribe. Comment down below how this video was and whatever your doubts are. Bye, guys.